Thank you. At ABARES, we've been doing a lot of modelling recently, looking at the effects of climate variability on farm profits. We actually released a report towards the end of last year and had a lot of those results. And this talk that I'm going to give today draws heavily on that report. So if you're interested in getting into the detail, please head to ABARES website and have a look. So this is why we worry about climate variability, because it has quite a dramatic effect on farm profits. These are ABARES average broadacre farm profit numbers since 2000, and you can kind of see the dramatic effect that drought has, with big downturns in those drought years 2003, 2007, and obviously the last two financial years have been heavily drought affected as well. Those numbers actually, if anything, understate the effect of drought on an individual farm. So this is a national average. Even in those severe drought years, there's some parts of Australia that aren't drought affected. So the effects on the drought affected farms are bigger than that. The other thing that's challenging with these numbers is that there's obviously a lot of other things that affect farm profits other than climate, including commodity prices, changes in technology, farm size over time. So if you really want to isolate the effects of climate, you need a model. So this is ABARES' model. We call it farmpredict. It's a data-driven model based on ABARES' long-running farm survey data linked to various forms of weather data. That model gives you a predictive framework, allows you to look at an individual farm, and then, given the commodity prices and the weather conditions that farm faces, simulate the likely outcomes for that farm, including the production of a range of outputs, the revenue, the use of inputs and the costs, and importantly the changes in stocks, which is including changes in grain and livestock herds, which is important in beef and sheep sectors because the effects of drought tend to impact herd size more so than they do short-term revenue and cost. So we also have to worry about climate change. The Bureau of Meteorology do a really good job of summarising all of the trends in the Australian climate to date, and all of the various forms of evidence are linking those trends with climate change. I'll just go very quickly through these points. It's getting warmer. Higher average temperatures across Australia, more than a degree of warming over the last 100 years, most of that since 1950. There are trends in rainfall, declines in average winter rainfall in southern Australia, and increases in summer rainfall in northern and western Australia. And we're also getting some more extremes, so more heat extremes, and there's also a trend, albeit a slightly weaker trend, towards more heavy rain events, so getting a higher percentage of our rain in narrow events as opposed to being spread out over time. So in this report that we did before Christmas, we looked at the effects of all of these long-term climate trends on farm profits. We take our model and we simulate the current set of farms, current technology, current farm size, current commodity prices, hold all that fixed, and then throw the last 70 years of climate data at these farms and see what that looks like. So these results show the average percentage effect of climate on average farm profits since 2000 relative to the long-run average to that 50-year period pre-2000. And you can see that that post-2000 period has been relatively poor compared with the long-run average. Our report estimated a 22% decline in average broadacre farm profits due to the effects of climate. That was not including the 2019-20. So at the end here we have now a forecast for 2019-20 financial year, and includes weather data up till January. And that is looking 2019-20 shaping up to be a fairly severe drought year, similar to 2019. When you include that, the average effect over since 2000 is minus 25%. The other thing that we're picking up is there's been an increased frequency of severe drought years. So the worst 4 years in the 70-year sequence that we ran are all since 2000. That's 2003, 7, and the last 2 years that we've just had. And actually the fifth worst year was 95, so that wasn't that far away either. So while the effect has been negative overall, it hasn't been uniform. Some regions have been affected more than others, and some regions have actually had some gains. So southeastern Australia and southwestern Australian cropping zones have been particularly affected by the declines in winter rainfall, so we've had larger negative effects of climate in those areas, and the livestock sector as a whole has been less affected, but There are some livestock regions where we're starting to see some effects emerging, so northern New South Wales, southwestern Queensland, areas where there's a bit of a downward trend in the climate, and these are predominantly livestock farming zones. You also see some areas of blue up in northern Australia where some high summer rainfall has actually benefited farms in those areas. So all of this is kind of at a national average industry level, which kind of hides the extent of the changes a little bit, because at a farm level things are a bit more dramatic. So these results give you a picture of what it means for an individual farm. This is a model simulation for a typical Australian cropping farm, and those results firstly show you the distribution of profits based on the long-run average climate, so the pre-2000 climate conditions. So for that typical Australian cropping farm with the historical climate, you would be making a profit of $250,000 or more around 40% of the time, 4 years in 10. We move our way down through the average years, below average years, down to the more severe drought years. You would be losing money, having a negative profit in about 1 in 10% of the time. And if we look at just the last 20 years, that's a very different pattern. So you can see it's really flattened the distribution, and you have a similar frequency of those average to below average years, but you have a much higher frequency of these severe drought outcomes. So that typical cropping farm now gone in the last 20 years from a bad, losing money outcome 1 in 10 to 1 in 4. And those really good years have become less frequent as well, basically halving in frequency. So this change in climate has lowered average farm profit. It's also increased the climate-related risk that farmers face, particularly cropping farmers. So I don't want you to get the impression that I'm all doom and gloom. It's important to point out that while climate has had a negative effect on farms over this period, climate's not the only thing that's changing. Obviously, farms are doing a lot, and there's a lot of adaptation and structural adjustment in the industry, and most of that change is having a positive effect on profits. So these numbers compare 1990 farms with current day farms using our model. This is an estimate of the average farm cash income across the whole broadacre sector based on 1990 farms with 1990 prices and historical climate. That's $87,000. If we add in current commodity prices, we're up quite significantly. Mostly that's the increases in beef prices, in lamb and wool that have happened since 1990, which have significantly increased farm cash incomes. You add in current day farms, you go up quite significantly again. A lot of that's to do with farms getting bigger, particularly in the cropping sector, where farms have more than doubled over that period. And it's also to do with new technologies that can be adopted on bigger farms. And then we add in all of the other technological advancements and improvements in management practices that have happened over that 28 years. And suddenly you're looking at 2018 farms having an average farm cash income of $196,000. So you've had more than doubling of farm cash income over that period, based on all of the other things, the adaptation, the innovation, structural adjustment, commodity prices, outside of climate. So while climate's working in one way, these things are kind of helping to offset that. All right, so a really important question is climate change. Where are we going? We know the last 20 years have been particularly poor, but what we really want to know is what's the next 20 years going to look like. Unfortunately, that's a difficult question to answer because there's still a lot of uncertainty, but I thought it'd be useful just to have a bit of a look at some of the climate change projections. So these numbers are for changes in summer maximum temperatures, and the red lines there just show the observed change over the last 20 years relative to the preceding 50. So this is the temperature increase that we've kind of seen already for these particular farming segments, so cropping farms in northern, southern and western Australia, beef farms in northern and southern Australia. And then we can overlay projections. These projections are coming from a range of different climate models and for different emission scenarios, so you get quite a range. There's a pretty clear story though that by 2050 temperatures are most likely going to be higher than what they've been in the last 20 years. The uncertainty is just about the magnitude of that increase. And a lot of that uncertainty is to do with the emissions scenario. So what happens to global emissions, how much more emissions are released between now and 2050. With rainfall, you see a much more mixed picture. So we've seen declines in winter rainfall with a similar percentage magnitude across all of these farming segments so far. And the projections I add in there. So you see there's a bit of a mixed picture about what the future direction might hold for rainfall. In all of those regions, with the exception of the western cropping farms, you'll see that the change that we've had over the last 20 years is actually more severe than the mean projection for 2050 that we've got there. So there's potentially some good news there that a significant number of these climate models are suggesting that winter rainfall may be better in 2050 than what it has been in the last 20 years. That's the kind of optimistic way of looking at it, but there's also a lot of uncertainty, and there is a potential with a number of those model runs that winter rainfall actually gets worse. Probably the only region where there's a little bit of clarity in the direction of rainfall is in southwestern Australia. So there's quite some very clear observed trends that have happened so far, and there's more agreement amongst the climate projection models about that there will be winter rainfall decline in the future in that region. So the mean projection for those western cropping farms is for another significant reduction in winter rainfall relative to what they've already had in the last 20 years. Although again, there's uncertainty about the size of that, and we need to take into account the fact that there are other things happening in that region, including increases in summer rainfall that have helped to offset the effects. So just quickly touch on some of the policy aspects of all of this. So clearly adaptation, innovation is crucial. We've seen what those processes have been able to deliver historically, and with changing climate, these things are going to be more important. Anything we can do to help the farm sector adapt and innovate and deal with dry conditions is really important. The other thing that's important is making sure we don't do things that unnecessarily slow down these processes. So ABARES has kind of made this argument a number of times in recent years about some of the challenges with drought support. Drought support can be beneficial to farmers at the time, but it can have long-term consequences. It can potentially slow down adaptation, innovation in the sector. It can potentially slow down structural adjustment. And we know how important these processes are for the industry as a whole. Now, economists like myself are quite fond of pointing out the problems with drought support, but it's important to acknowledge that there is still a problem here. So farmers are exposed to an extraordinary amount of climate risk, and they face more risk than other sectors, and with climate change it appears that climate-related risk is increasing. The risk that farmers face is a constraint on the industry. It makes it harder for farmers to be ambitious and bold in the way they run their farms, to be innovative, and it makes it harder for them to attract finance and investment, particularly debt finance. So the high level of risk that farmers face is a constraint on the growth of the industry, and particularly when we're thinking about moving towards a $100 million target. Anything we can do to try to mitigate that risk would really help. And here, something that's been a long-term goal has been markets for drought insurance. Obviously, drought insurance has proven to be a pretty difficult nut to crack in Australia and internationally, but there is some hope for the future. We think one particularly promising area is index-based insurance. So here we have products where payouts are tied directly to weather data. Index-based insurance is not a new idea. It's been around for a long time, and it's always had a lot of theoretical merit. It's always been about getting the details right. So getting the data and the models and being able to build indexes that are accurate enough to actually make the index products viable. This idea about building the data and building the information and technology that we need to support index-based products is something that motivates a lot of ABARES work in this area. It motivates a lot of the farmpredict work that you've seen. It also motivates a lot of the work that we've been doing with the ABS. I'll just also mention that there's a lot of other people working in this area, and we'll hear a bit more today from the other speakers about index-based products and some of the other things that other agencies, including Bureau of Meteorology, are doing to try to create the data and the infrastructure to actually make that a possibility. So thank you.